In this problem, we're going to build a fifth-order polynomial with some facts. We have an imaginary 0 at 2 plus I, we have a touching 0 at 1, a crossing 0 at -2, and a y-intercept of 20. The hardest part is the imaginary 0 part. Let's start there. If 2 plus I is an imaginary 0, then the corresponding factor is x minus 2 plus I. Now we know that imaginary zeros come in pairs, so we also have that 2 minus I is a 0. In order to start building our polynomial, we'll need to multiply these two factors together, getting a quadratic expression. Now to do this, you could distribute the minus sign and do a bunch of distribution, or there's a clever little trick that I will use here. What I'm going to do is group the x minus 2 together. And so when I FOIL, I'm going to think of the x minus 2 as one term. So in other words, when I FOIL, I'm going to think of x minus 2 as the first in each of these factors. And then the negative I and the positive I will be the last. All right, so let's go ahead and do that. So when we distribute, or well, I shouldn't say distribute, when we FOIL in this process, we'll have x minus 2 squared. And now when we do inner and outer, this is where we have to be careful. Notice that the inner and the outer will add to 0. For the inner, we'll have negative I times x minus 2. For the outer, we'll have positive I times x minus 2. Those cancel. And then for last, we get minus I squared. So this will turn into, let's FOIL that out now, x squared minus 4x plus 4. I squared is -1. So we'll have a negative 1, which is plus 1. We now have a quadratic, x squared minus 4x plus 5, that has, as its two zeros, 2 plus I and 2 minus I. All right, now let's keep building. We have to get all the way up to a fifth order polynomial. Let's go ahead and take our touching 0 and work with that. So our touching 0 was at 1. So x minus 1 would be the corresponding factor. But x minus 1 will not be that will be a crossing 0, not a touching 0. To get a crossing 0, we're going to have to multiply that by itself. We'll have to raise it to the second power. If we multiply this out, we'll have x squared minus 2x plus 1. So we have to now combine these two polynomials together. If we multiply those together, we will get a fourth order polynomial. Let's go ahead and do that. So we'll have x squared minus 4x plus 5 times x squared minus 2x plus 1. Multiplying all that together, it's going to be long. We have to distribute the x squared to each of the three terms. So that's x to the 4th, and then minus 2x cubed, and then plus x squared. And I'm going to stack here so that I can keep track of the corresponding powers. Now I'll distribute the negative 4x across. We'll have negative 4x cubed. Let me put that in the right place. Negative 4x cubed. And then we will have positive 8x squared. And then we will have negative 4x. Now we distribute the 5 across. We'll have 5x squared minus 10x plus 5. Now all that needs to be added together, giving us the polynomial x to the 4th minus 6x cubed plus 14x squared minus 14x plus 5. Excuse me. We now have a fourth order polynomial that has all the zeros that we need. There's one more zero we have to take into account, and that zero is the crossing zero at -2. The corresponding factor for that crossing zero is going to be x plus 2, so we now need to multiply this big polynomial by x plus 2. So let's go ahead and do that. Again, we'll have to distribute the x all the way across. And when we do that, we get x to the 5th minus 6x to the 4th plus 14x cubed minus 14x squared plus 5x. Now we distribute the 2 across. 2 times x to the 4th is positive 2x to the 4th. And then minus 12x cubed plus 28x squared minus 28x, and then plus 10. These now need to be added together. So add those up. And now we're up to a fifth order polynomial, x to the 5th minus 4x to the 4th plus 2x cubed plus 14x squared minus 23x plus 10. This is a polynomial that has all of the zeros needed. It's got a power of 5, but notice the y-intercept is 10. We were told that we wanted a y-intercept of 20, so let's see, what can we multiply this polynomial by that won't change the zeros, but will change the y-intercept? Well, the answer is to multiply by the constant 2. If we multiply by the constant 2 all the way across, we will end up with a polynomial that has the exact same zeros as the polynomial above, but it is going to have a y-intercept of 20. This is a non-trivial problem. Lots of little steps, but we've done it one step at a time. The biggest issue, multiplication. Lots of foiling. Good luck.